Picture this. You've been sitting at your desk for 6 unbroken hours. Your textbook is open, you've read the chapter 3 times, and you've color-coordinated every important paragraph with a neon highlighter. You close the book feeling prepared. But the next morning, you sit down for the exam, look at the first question, and your mind goes completely blank. That blackout happens because rereading and highlighting are scientifically classified as low-utility study methods. They offer almost zero measurable improvement to your long-term memory. You fell into what cognitive psychologists call the illusion of competence. Your brain confused the ease of recognizing a familiar text with the actual ability to retrieve that information from scratch. Fluid, comfortable study sessions are often a sign that learning has stalled. True retention requires friction. To break that illusion, you need a high-utility solution called active recall. One of the most direct ways to do this is the blurting method. You close your books, grab a blank piece of paper, and write down absolutely everything you can remember about a topic. Then you open your notes and fill in the missing gaps with a different colored pen. This forces you to confront what you actually know, which aligns perfectly with the philosophy of Nobel laureate Richard Feynman. He realized that students often use complex academic jargon to mask their own lack of understanding. To strip away that mask, you can use the Feynman Technique. Take a complex concept and explain it out loud in simple language, as if you were teaching a 12-year-old. The moment you stumble or resort to jargon, you've found a blind spot in your memory. Forcing your brain to actively output information builds and solidifies physical neural pathways. Passive reading just temporarily stimulates the ones already there. Even if you build a strong neural pathway today, biology works against you. This natural decay is known as the Ebbinghaus forgetting curve. This graph plots memory retention over a 7-day period. It shows us exactly why massed practice, or cramming, fails. After your initial study session, there is a steep exponential drop-off. You will lose up to 80% of that crammed information within just a few days. You can interrupt this decay using spaced repetition. By reviewing the material at specific, expanding intervals, like days 1, 3, 5, and 7, you reset the curve higher each time, and the drop-off flattens out. The timing here is critical. The optimal time to review a piece of information is the exact moment your brain is struggling and about to forget it. Mastering memory is a function of precisely controlling the timing of your study sessions. Your brain processes different subjects using specific memory systems, which dictates the type of practice you need. STEM courses rely on procedural memory, the ability to apply formulas to novel problems. Humanities courses rely on semantic memory, which requires you to synthesize ideas and construct arguments across multiple texts. For STEM, the most effective strategy is interleaving. Instead of doing 20 identical math problems in a row, you mix different problem types together. This forces your brain to figure out when to apply a specific formula, rather than just blindly repeating a solution pattern. The Pomodoro technique, 25 minutes of focus followed by a 5-minute break, manages the biological limits of your attention to prevent cognitive overload. You can optimize this further by engineering your environment. Exposure to 480 nanometer blue light suppresses melatonin and increases cortisol to sharpen your focus, while instrumental lo-fi soundscapes help maintain flow states without distracting your language centers. Success depends on matching your study techniques to the specific demands of your subject, while respecting your brain's biological limits. Effective studying is defined by the intensity of cognitive retrieval, regardless of how many hours you spend at a desk or how many pages you read. The friction, the frustration, and the mental exhaustion you feel when trying to remember a concept without looking at your notes is the exact biological mechanism required to build a permanent memory. Abandon the neon highlighters. Pick up a blank sheet of paper, set a strict timer, and do the uncomfortable work of trying to pull that information from your own head. Real learning is an act of physical, mental labor.